In this lab, we will continue with trees in ensemble methods applied on biodegradable dataset. The purpose of this lab is to get experience with the performance of tree-based models and some ensemble methods. Step 1. We read the data file from the website. Step 2. We explore data analysis by plotting box plot for each variable in the dataset. And we also plotted the histogram for each of the variables in the dataset to show the distributions. We also identified all the missing values in the data, but there was none. Then in step 3, we showed feature engineering. We created 2 new variables, NHMNO and NNN NCRX3. We encoded the categorical variable class using label encoder. We splitted our data into 50% training and about 50% test set. We performed scalar on both training and test set columns. Step 4. In step 4, we developed the models. We developed the classification tree, and we found that 22 variables were actually used in the tree construction. We plotted the unpruned tree, and we pruned it using the cost complexity, and we also pruned it using the size. And we found out that pruning it by size gave us less test error than pruning it by the cost complexity. In this lab, we are going to perform bagging method. In the following code, we produce a bagging model for the training data with 500 trees constructed. Names of the trained data set is we have 42 trained data set. And the last column, class, is the response variable. So what we will do, we will select the number of predictors to model by random forest method. Let P equal length of names of train minus 1, and that gives 41. Random forest fit, mtry equal all predictors. Now we construct the random forest tree. Let R equal random forest bracket class equal addition of all the predictors, comma, data equal train, comma, mtry equal P, which is the length of 41 variables, comma, importance equal true. So we get random forest model for 41 predictors. Number of trees is by default 500. Number of variables tried at each split is 41. Our V is estimate of error rate, which is 17.23%. Confusion matrix. So we have the predicted class values and we have observed class values. So the misclassification rate is we have misclassified 33 values are misclassified for NRB and 58 values for RB is misclassified. Show working. Call names of R at A dot right is OOB, NRB and RB. In the following code, we plot to show that 500 trees are good for estimating errors. Plot of R, main equal error rates, legend of top right, legend equal call names of R at error rate, LTY equal 1 to 3, call equal 1 to 3. Comment: the plot shows that 500 trees are good for estimating errors, as the error rates of classes NRB and RB stabilizes and there seems to be very less variation in error rates for more than 500 trees. The black curve for class OOB represents the out-of-bag misclassification error rate for 500 tree. In the following code, we find the three most important variables in terms of decreasing the Gini index according to bagging. Importance of R, print first few rows of importance of model. So head of importance of R is printed like this. So we will sort the variable importance in terms of decreasing the Gini index. So let var1 equal sort bracket importance of R square bracket comma 4 means fourth column comma decreasing equal true. The three most important variables we found are SP max BM, SP max L, SP pos ABP. Print the first three important variables. So var1 from 1 to 3 is SP max BM, SP max L, SP pos ABP.